6.5 first question. Third one. We have to find the maximum and minimum value, if any, for the function. So consider the first one. Here f of x equal to minus of x minus 1 whole square plus 10. We have to find the maximum value or minimum value. First consider, we know x minus 1 whole square. We know about the perfect square. X minus 1 whole square is always greater than or equal to 0 for every x belongs to R. Now we can consider the function. We want to get the maximum or minimum value of the function. So minus of x minus 1 whole square. We want minus of x minus 1 whole square. So in this inequality, we have to multiply by negative. So when we multiply by negative, we have to reverse the inequality. So negative of x minus 1 whole square less than or equal to 0 into minus 1, that is 0. So inequality reverses when you multiply by negative. Now we want to add 10 plus 10. So we can add 10 both sides. So plus 10, when we add here, we get minus of x minus 1 whole square plus 10 less than or equal to 0 plus 10. That is same as 10. And this is same as minus x minus 1 whole square plus 10. That is f of x. So f of x less than or equal to 10. So we got for every x, real number x, f of x is less than or equal to 10. So this is the maximum value. So it is always less than or equal to 10. That means 10 is the maximum value. Therefore 10 is the maximum value of the function. 10 is the maximum value of the function. And there is no minimum value. Now fourth one, g of x equal to x cube plus 1. X cube plus 1. Here it is x cube plus 1 means as x increases, f of x, g of x also increases. And when x tends to x become infinity, very large, g of x also become very large, tends to infinity. Similarly, when x tends to negative infinity, becomes smaller, g of x also becomes smaller. Therefore, there is no maximum or minimum value. So there is neither, it has no maximum value, no minimum value, this function, g of x. Now, second question, first one, same. Second question also we have to find the maximum value or minimum value of the function. F of x equal to modulus x plus 2 minus 1. So first here modulus function. We know modulus function always greater than or equal to 0. Modulus x plus 2, that is always greater than or equal to 0. Modulus of any number, any real number, whatever be the real number x, modulus x plus 2 greater than or equal to 0 for every x belongs to R. Therefore, we want here modulus x plus 2 minus 1. So we want to add minus 1 both sides. So when we add minus 1, what we get? Modulus x plus 2 minus 1, or subtracting 1 or adding minus 1, both are same. Greater than or equal to 0 minus 1. So this is same as f of x. So f of x greater than or equal to 0 minus 1, that is negative 1. So f of x is greater than or equal to negative 1. That means for every real number x, f of x is greater than or equal to minus 1. That means minus 1 is the minimum value of the function. Therefore, minus 1 is the minimum value of the function. And there is no maximum value. Now, consider the next question, modulus x plus 3 minus modulus x plus 2. Second question, g of x equal to minus of modulus x plus 1 plus 3. That is same type. First consider modulus x plus 1. Modulus x plus 1 greater than or equal to 0. So we want minus modulus x plus 1. So both sides multiply by negative. In an inequality, when you multiply by negative number, multiply or divide by negative number, inequality should be reversed. That you remember. So here, when we multiply by negative, minus of modulus x plus 1 less than or equal to 0. Then we have to add. So minus modulus x plus 1 plus 3 less than or equal to 0 plus 3. This is same as g of x. G of x less than or equal to 3. So that means for every real number x, g of x is less than or equal to 3. So 3 is the maximum value of the function. Therefore 3 is the maximum value. 3 is the maximum value of the function and there is no minimum value. Now next third one. Third one, h of x. Hx equal to sine 2x plus 5. Sine 2x plus 5. We know sine function, cos function. Sine function always lies between minus 1 and 1, including minus 1 and 1. So we can write minus 1 less than or equal to sine 2x less than or equal to 1. That we know. Sine of sine function always between minus 1 and 1. So minus 1 less than or equal to sine 2x less than or equal to 1. We want to know whether sine 2x plus 5. So we have to add 5. In this inequality, we can add 5 to each term. So each expression, this one. So we add 5. Minus 1 plus 5 less than or equal to sine 2x plus 5 less than or equal to 1 plus 5. Add 5 in each term. So we get 5 minus 1, 4 less than or equal to sine 2x plus 5. That is same as our function h of x. H of x less than or equal to 6. So h of x is always less than or equal to 6 and greater than or equal to 4. So this is always less than or equal to 6 means 6 is the maximum value of the function. And this is always greater than or equal to 4 means 4 is the minimum value of the function h of x. Therefore 4 is the minimum value. 4 is minimum value of the function h of x. 4 is the minimum value of the function h of x and 6 is the maximum value. 6 is maximum value of h of x. So this is the minimum value and maximum value of the function. Now consider the fourth one. Fourth, modulus sine 4x plus 3. That is the function f of x equal to f of x. Modulus sine 4x plus 3. We know sine 4x. Sine 4x lies between what? Minus 1 less than or equal to sine 4x less than or equal to 1. That we know. Now we want sine 4x plus 3. So we can add 3 to each term. So we get 3 plus minus 1 less than or equal to sine 4x plus 3 less than or equal to 1 plus 3. So 3 minus 1, 2. So we add 3 to each term. 3 plus minus 1, that is 2. Less than or equal to sine 4x plus 3, that is sine 4x plus 3 plus 3. That is less than or equal to 4. So sine 4x plus 3 lies between 2 and 4, including 2 and 4. So that means, see, these are between 2 and 4 means these are all positive numbers. So we can write, instead of sine 4x plus 3, we can write modulus sine 4x plus 3. Because modulus sine 4x plus 3 is sine 4x plus 3 itself. Because it is already positive. Between 2 and 4 means that is positive. So we can write 2 less than or equal to modulus sine 4x plus 3 less than or equal to 4. We can write modulus because it is already a positive number. Now what is this modulus? That is the function f of x. So 2 less than or equal to f of x less than or equal to 4. So what is the minimum value and what is maximum value? F of x less than or equal to 4. So 4 is the maximum value and it is greater than or equal to 2. So 2 is the minimum value. Therefore 2 is the minimum value. 2 is the minimum value of the function and 4 is the maximum value. So 4 is the maximum value, 2 is the minimum value. Now next. Fifth one, h of x equal to x plus 1, where x belongs to open interval minus 1, 1. So here, it's a special function that, see here the domain is x belongs to minus 1, 1, open interval. So in the open interval, the function has no maximum value and no minimum value. If you draw the graph of this function, h of x equal to x plus 1, see when x equal to 0, h of x equal to 0 plus 1, 1. x equal to 1, h of x equal to 1 plus 1, 2. 2. X equal to 2, 2 plus 1, 3. So if you draw the graph, what we get? 0, 1. When x equal to 0, y equal to 1. X equal to 1, y equal to 2. 1, 2. Then 2, 3. So the line is like this. It's a straight line. Minus 1 to 1. So x equal to minus 1. X equal to minus 1 plus 1, 0. Here 0. Minus 1. When x equal to minus 1, this point, minus 1, 0. So that point, this is the line. And x equal to 1. The line is only from minus 1 to 1. So when x equal to 1, y equal to 2. X equal to 1, y equal to 2. So only that line from minus 1 to 1. So when x equal to minus 1, y equal to 0. When x equal to 1, y equal to 2. When x equal to 1, y equal to 2. So that only in that open interval. So minus 1 to 1. This is 1. Suppose it is 1, 0. So 1, 1. So that point is excluded from the graph. So these 2 points are excluded from the graph. Therefore, it is an increasing function. But it has no maximum value because here when x equal to 1, y equal to 2. When x equal to 1, y equal to 2. But that point is not included in the graph. That is open interval. Minus 1 and 1 are not included. So we don't know which is the number. When x equal to 1, the value of y is 2. But less than 2, what is the value which is closest to 2? That we can't say. Similarly here also, when x equal to minus 1, y equal to 0. But next, more than that, what is the closest value? That we can't say. That is why in the open interval, the function has no minimum value, no maximum value. So here the function has no maximum and no minimum value. Now, one term, monotonic function. Monotonic function. Monotonic function means increasing function. If a function is increasing in I, consider one interval I. So if the function is increasing in I or decreasing in I, we say it is monotonic function. And in the monotonic function, in a closed interval, it has the maximum value and minimum value at the end points. See, in this case itself, if the interval was closed interval minus 1, 1, then the function has maximum value at x equal to 1 and minimum value at x equal to minus 1. So in the closed interval, monotonic function has maximum value or minimum value at the end points. So at these end points, it has the maximum or minimum value, which is increasing according to increasing or decreasing function. Okay, let's